Good morning. How is everybody? I'm Seth. I'm the person that'll be doing the questioning. This is Govind. He's the one who'll be doing the answering. I'm not sure where he's going. Oh, he's going to get the clicker. The reason he's doing the answering is he's the smarter one. I'm literally here to be someone that doesn't understand so much. And so I think that I got from the first couple of sessions, we were talking about ethics a little bit in the first panel. And then we were just being told that all we got to do is get our data right. And then everything's easy after that.
That's right, Seth.
Yeah.
And that's the little problem we're trying to solve, right?
Yeah.
For everybody. So I was actually, before we get started, I'll tell you, I don't know how many of you watched Seinfeld, but I still remember him picking out a cue where he said the #1 human fear was public speaking, right? I don't know how many of you knew that. And the #2 was death.
Indeed.
Yeah. So I actually Googled that before I came in.
Yeah.
And so I told them to put the mic on my right side so you can't hear my pounding heart. Right? But essentially, death has actually fallen down to #5.
Look at that.
Yeah. But the important thing is, if you took that data and gave it to any sensible AI engine,
Yeah.
it would clearly tell you to jump into the casket
Right.
rather than giving the eulogy, right? And so I think we're still some time to go for common sense.
Yeah.
But it's a very exciting time.
Yeah. Some might argue that actually curating and managing data for artificial intelligence would be the new #2, right?
I would absolutely think so.
So I think that we all come, and I'm speaking to corporate enterprise practitioners all day long at the AI and Intelligent Automation Network, which is on your computer at AIIA.net. And essentially, it's all about that. What data do we have? What data do we know about? What's our structured data? What data do we not really have control over? What's our unstructured data? And how are we going to measure that and get on top of it? And one good option is to go the neural networks route. And when we first started talking about this conversation, obviously, this was not this slide that you're seeing was not put together by somebody that was on peyote. This is the pattern of the sentences.
That's right.
That is the title of this session. So there's an alternative to neural networks, and what's that?
So what happened was when we actually started out, and the last session from Gartner is actually fantastic, right? Because it really tells you, it lays it out that you've got to do this. If you're not going to do it, you're putting your business at risk. But we're going to actually get slightly narrower about, yeah, we need to do it, but how do we do it, right? And when we looked at it as a company, we kind of said, hey, listen, if you look at AI historically, there have been a couple of winters, right? And from 1956, when it started in Dartmouth, the problem was there wasn't enough processing power. And then they moved on, and they found there wasn't enough data. Mm-hmm. And then they found that there was not enough investment. Mm-hmm. And then the problem comes to adoption, right? And so right now we're sitting at a point where you're almost at a perfect storm, right? You've got the data, you've got the processing power, you've got the investment, and adoption really becomes the key success factor, right? Mm-hmm. And that's why this community here really needs to be able to adopt it. And so what we found when we looked at it was that if you look at adoption, there are certain inhibitors which come in the way of adoption. And some of those challenges were things like data availability, right? So a lot of organizations struggle with finding the data that they need. Once you have the data, the second challenge that we saw was data usability. So you can have data, but is it ready to be used? I mean, we're dealing with a bunch of companies which have data lakes, and I met some people here as well, and they have the data lakes, but they don't know what to do with the data lakes. Because now you've got all this data sitting in a data lake, but you can't harness it for machine learning, right? So that was, again, a big challenge. The third was processing power and GPUs and the infrastructure and investment which is required, which is also a problem. So personally, whenever somebody tells me neural networks, I've got this image in my head, and I don't know how many people have it, which is essentially of a room full of big blue machines and people wearing doctor coats and walking around, right? So it's very intimidating. And so when we looked at all these problems, we started looking at, is there another way to do this? And that's where we actually found fractal networks, which is a different science, and which actually lent itself to tick a lot of those boxes, right?
And I think within what you just shared, one of the things that I hear all the time from corporate enterprise practitioners is, first off, I don't have the computer science talent, to manage this in any real way. I'm a good strategy person, I'm a good business person, I might even be a good IT person, but as far as being a data scientist, I ain't one. Yeah. And I don't see a lot of folks out there that have the commensurate experience to do what we need to do. There's like 5 people at Stanford.
You're absolutely right. So that's going to be another inhibitor, basically. Yeah. So if I just tell you a little bit more about conceptually how the science is different, it'll kind of bring out a lot of the benefits, right? So if you look at fractals as a science, the basic fundamental principle which separates fractals from neurals is that neural networks focus on absolute values, right? And fractal networks actually focus on patterns. And we really believe, and I might be making a controversial statement here, that the human mind really works with patterns more than absolute values, right? So take, for example, Seth, if I saw you in Grand Central 10 days from now, and you're standing at a 45-degree angle, I'm sure I'd be able to shout out and recognize you, right?
Yes.
And I'd be able to do that not because I remember the distance between your eyes and the exact structure of your face. I'd be able to do it because I can recognize the pattern. Yeah. And so the underlying philosophy is patterns are more important than absolute values, right? Even if you go back to ancient Indian medicine, they actually picked out physicality of people and actually understood those patterns. So a good Ayurvedic doctor could actually see you when you walk through the door and see your physicality, the shape of your nails, the shape of your eyes, the shape of your facial structure, and actually tell you you're susceptible to these 5 diseases, right? With a severe amount of accuracy. So patterns really become more important than absolute value. Now, if you understand that concept, that has a lot of ramifications, right? For example, the minute you start talking about patterns, fractal networks are essentially really looking for self-similarity. And they're looking for resonance of self-similarity. And so they're actually converging on that self-similarity and learning from that, right? So fractal becomes a very deterministic science, right? While if
you have a slide, I think, that kind of gives in 4 quadrants, right?
Yeah.
Here's a little bit of background. Sure, that's fantastic.
So if you look at really the fractal network itself, the fact that it stresses that patterns are actually more important than absolute values. So as a science, it's basically converging on the data, and it's trying to find the resonance in the data and actually work in a deterministic manner. And when you talk about neural networks, you're looking at absolute values, and then you're applying probability to actually move down the tree. And so you're actually on a divergent journey.
Yeah.
Right? And that really becomes the differentiator between the two.
But on that divergent journey, when I do have enough data scientists to kind of harness all that data and actually do all that work, I do have a sense of precision that it feels like, from what you're saying, I don't get from patterns. Patterns feel messy to me, just how you're describing it, right?
That's a great question.
And I admit to not being a data scientist by using a word like messy.
Super. So that's where I'd actually focus on the word deterministic. And because it's not working off probability, it's like it's going to rain in Boston, and the probability of rain in Boston is 30%, is what your neural network will tell you. But what the fractal network will tell you, it will converge on the data and tell you in a deterministic fashion that it will rain in Boston, and my confidence level for that is such and such. So in a way, the fact that it's deterministic, and when you add heuristics to it, it actually becomes a lot more revealing. What
happens if we get kind of off on a tangent and we go down the wrong path here, right? We're looking for rain, we find rain, and that turns out to not be it at all. It wasn't rain. It was frogs.
That's where while you get the deterministic outcomes with confidence scores, it allows you control on how to adopt them, right? So it does become a controlled environment. And there is something known as dimensionality reduction, which basically means when you're looking at a pattern versus an absolute value, you can actually eliminate some of the dimensions, right? So for example, scale invariance. Scale invariance means if you're actually teaching a neural network, what an apple is, you've got to tell it what's a small apple, what's a big apple, what's a medium-sized apple.
Top of apple, bottom apple, side apple.
So you look at the data set that you're dealing with, it gets a lot more absolute value focused. In fractal networks, it'll just pick up the patterns of the apples and apply scale invariance, right?
Yeah.
So if you look at these 4 or 5 different things that I've just spoken about, right?
Yeah.
And you go back to some of the challenges that we were seeing, it really boils down to, from a business perspective, there are other ways to do machine learning. And with fractals, you can do it with smaller data sets to get the same level of yield, if not better at certain times. Lighter on infrastructure. So you don't have to go to a GPU environment or big infrastructure to get it done. And it's easier to implement because to your point, from data curation perspective, it's actually much lighter. So I don't need an army of data scientists to actually curate my data, make it absolutely right so that my neural network can take the right decision. So it works great, but hang on.
Yeah.
So I'm not saying one science is better than the other.
Sure.
The important thing is, what is the problem that you're trying to solve, right? If you're trying to predict the weather, you probably want to go neural.
Okay.
But if you've got a finite variance in your data set, and in our case, when we look at businesses are controlled environments, right? And your data variances are finite. There we're finding fractals to be actually much more fit for purpose, right?
Okay.
And if you look at businesses are actually designed for controlled behavior. You're designing your business for certain outcomes within your processes, right? Yeah. So for us as an organization, when we focused on the specific problem that we're dealing with, we actually found fractals to actually fit in very well.
So that's helpful because rather than choice between rain and frogs, your point here is there are no frogs. I was going to ask you apples and pears, because a pear kind of sort of looks like an apple, and if I'm just doing patterns, I might mistake it for a pear. I think the environment you're talking about, the business environment you're talking about, doesn't have any pears.
Correct.
So you don't have to worry about it.
Exactly.
As long as it's close enough to an apple, here's your answer.
Exactly. So that's why we found it to be very fit for purpose. And so we've actually applied it across various sorts of problems that we've tried to solve with it. Right?
Such as, here we go. This is the stuff. Open up the notebooks.
Open up. So actually the most interesting one for us is, which lends itself to everything which the Gartner pack was talking about. And in the last slide, he summed it up. You really need to be able to demystify your data, because if you don't have data, you cannot do machine learning, because what's the machine going to learn from, right? So we've kind of applied fractals to totally do away, and sorry for being very, very blunt, but with this rubbish technology called OCR. Oof. Which we call
That's rough. Everybody loves OCR. Everyone want more of it. Come on.
I personally call it obsolete character recognition, because it was good to use OCR till about 5 years back when people weren't trying to automate. But the minute you start trying to automate, you quickly realize that that's your biggest bottleneck, right?
Interesting.
So what we've done
the goal should not be to plug into OCR. No, but that's what I hear.
Yeah. And the idea is that we've basically taken image recognition and we've married it with pattern recognition and machine learning. And so now you've got something which is actually reading the documents with some context and not just picking information without any context and bringing it out, right? Mm-hmm. So that's one big problem statement that we solved. But you take the same science. We looked at something known as natural language processing, which I'm sure everybody knows, and which is basically, taxonomy-based keywords tokenized together to actually get meaning out of sentences, right? So we again looked at the way it currently works, and we said, hey, listen, hang on, can we apply patterns to this? And we actually started applying patterns to grammar. And so now it's not only keywords, but the grammar and the sequence itself is starting to come into play. And so we were able to create what we call as natural language modeling. To give you a sense, I was talking to somebody yesterday, and they were like, I need to do a lot of work to get my NLP models going. And I was thinking in my head, hey, hang on.
Right.
It's not that much work, because we were working with a title company where we kind of automated their whole title process, right? And so we needed to read these legal deeds of trust and legal descriptions of properties to determine what sort of a property is it.
Yeah.
We asked them for 1,500 descriptions and 1,500 right answers. We uploaded it into the model. In 15 minutes, it was giving 85% yield, right? So again, you're just demystifying technology. You're applying patterns inside that. Same thing for robotics. I mean, anybody who's done robotics here, RPA, will tell you, RPA has this horrible thing which nobody talks about, but they talk about it behind closed doors.
Failure?
And no, it's called, I mean, what I call it as the exception discovery, right?
Yes.
And you put your bot and you think you've thought of everything, and then the minute it starts, you realize, hey, hang on, here's an exception.
Pops out an exception.
And here's an exception, and that exception discovery is a killer. As far as that journey is concerned. So why not apply patterns to actually do exception handling, right?
Yeah.
So to give you an example, if your bot is processing invoices and there's a marriage certificate in it, it should be able to sidestep and move on.
Sure.
And not come to a standstill.
But now you're talking about invoices, you're talking about, revenue. And again, I worry, especially from financial services, I'm highly regulated, and you're, just doing these kind of, quick pattern matching and everything should be fine.
Yeah.
How can I rest assured that we've got the right kind of findings here? With neural networks, we know because it goes from here to here to here to here. There's a nice tree, we can see it, it's all nice and neat.
Yeah, in this case, again, it goes back to the deterministic point, where you've got the deterministic way of doing it, and then you've got the heuristics, and then you've got the controls. And you are in control. And so if you say, hey, listen, if the confidence level of the algorithm is 85%, I want to look at it myself. Everything that's 90% and above, let them do it, right? So yeah, and if you look at it, it's the same technology which we're using for, we're tied up with one of the leading oncology thermologists to look at thermal signatures of breast cancer scans.
Okay, this sounds important. Let's actually breathe for a minute and talk about this, right? This is a great, this is life and death. So let's talk about that. Take us through it.
It's the same technology. Which is being used right from looking at invoices to looking at heat signatures in thermal scans and detecting breast cancer, right? Or pulling out high-risk cases for doctors, right? Same thing. Goes back to being able to see the patterns, work with the patterns, and then use them.
So have these doctors kind of tried to implement something else and now they're coming to this? Or is this a first go at automation for them?
This is a first go.
And what is their feedback to you?
Well, we've just started.
Okay.
And the initial results are pretty encouraging.
Give us anything to chew on.
I'm not going to give you any data.
Okay, fine.
But the point is that we've reached a point where it's got enough confidence to say, all right, I think we should go the whole hog.
Got it.
Yeah.
Okay. All right.
So
we're dealing with breast cancer, so we should be able to deal with legal documents from a title company.
Absolutely.
Can you give us maybe a couple of other case studies of where you've been playing, so to speak?
Well, the thing with fractals.
Because this is new, right?
Yeah, it is new. And the thing with fractals is, I don't know how many people saw Danny's session here yesterday, and brilliant guy, bright guy. And the minute he finished, I actually walked out and I wanted to shake his hand and congratulate him on all the fantastic work he's done. But I was also very curious to ask him, I said, Danny, have you heard of fractals? And he said, no. And I was thinking to myself, so this is really, and it's one of the oldest sciences, right? And it's been there since the 60s.
Fractals have.
Yeah, and it's being used by NASA, it's being used by Boeing, it's being used by all these different companies, but nobody has applied it.
Why are we just getting to this? If it's less compute, if it's less talent needed, meaning data science, less specific talent needed, why are we only getting to it now?
I'm asking the same question.
Fair enough.
And that's the reason I'm here talking about it. And we're pursuing it as an organization.
All right.
Yeah.
Okay, I'm just trying to see if there's the time. They said that there would be the time. I can't find the time. Who knows? 1 minute. So there you go. We got 1 minute left. I'll ask you the 3 final questions. I'll tell you what they are, and I'll ask you them in order. This is what we do on the podcast all the time.
That's a surprise.
Okay. What's most surprised you at work, along the path here? What's most surprised you in life, and on the soundtrack of your life, one track, one song that's got to be on there? First things first, what's most surprised you at work? How long you been at Antworks?
We started about 4 years back.
Okay. Why is it called Antworks?
Well, it was 3 in the morning when my co-founder called me. but the basic thing was that we really like the attributes of ants. I mean, they lift 50 times their body weight.
There you go.
They work great in teams together,
yeah,
and all sorts of wonderful things.
Yeah.
And we were definitely setting out to carry more than 50 times our body weight, so it fit right in.
And it seems like we can do that with Fractal even.
Yeah.
What has most surprised you at work?
Well, I think what surprised me at work is that as individuals, we're capable of so much more than we think we're capable of. Mm-hmm. And I've actually seen that in myself through this journey of a startup, right?
Right.
And I've seen it in the people that we work with, and so people have more than what they think they have.
They have more than what they think they have.
That's right.
They are capable of more than what they think.
They're capable of more than what they think they have.
I thought you were saying the inverse of that.
No.
I think for some that is true,
yeah,
but it's a different conversation. What's most surprised you in life?
What most surprises me in life, okay, this is going to be a little on the tangent, but I think every one of us knows deep in our heart that money is not going to give you happiness. But everybody still has a relentless pursuit for it. And I can never kind of get those two aligned, right?
Yeah, I think it's the system of capitalism that might be at play.
That's right.
We can discuss that later, though,
we can discuss that backstage, for sure.
So on the soundtrack of your life, one track, one song that's got to be on there, what would that be?
I would say it's Louis Armstrong, It's a Wonderful World.
Oh, look at you.
Yeah.
How wonderful is that? A wonderful world at AI World. Thank you so much for having us. Govind, thank you so much for your time.
Thanks, Seth.
See you down the line.